Okay, it's time to get started. We're going to go ahead and start. And I just want to remind you that we do have these recorded and they will be on my YouTube channel as soon as they get uploaded. Sometimes that's Thursday nights, sometimes it takes a couple of days, but they eventually make it onto YouTube. Okay, I always like to start out just to remind people the ways that I help everybody to learn how to grow food. And these are the 8 ways that I help. I'm working on my book, which is number 8. We're going to go backwards this week because I like to break rules that shouldn't be rules. So we've been working on my manuscript and it's harder than you think. But it's certainly worth publishing. So we're working through it this winter and getting it done. I was hoping it'd be done by Christmas. Not going to happen. Boot camp is coming up next month. I have a boot camp. That's a 3-day event. People can come here. They can learn from me hands-on. We go into my greenhouse and we get dirty. We dig in the dirt. We make compost and compost tea. We inoculate the ground with microbes. We plant seeds. We plant plants. We harvest what is ready, which isn't a lot at this time of year. What's today, the 22nd? Yeah, so yesterday was the shortest daylight hours of the year. So now our days are going to be getting longer, so the growing season is on its way. I'm a consultant. If you want to hire me to do consulting for your farm, I am a soil laboratory. I can test your soils to see if they function or not. I've got my 17-week farmer training course. That's probably the most exciting thing that I do when people can learn. And I have created this in such a way that you can come here, you can stay on site, you can work here. I mentor you solid for 17 weeks, you live here. Or you can stay home because most people have a life and we can zoom you into the classes that we do. You still get the same class. The hands-on portion you would do in your home gardens, and I mentor you through that process. Number 3 is the Patreon. That is my entire video library. You have access to all my videos. And as of last week, I had 505 posts on there. Most of them are videos about observation in the greenhouse, observation of what's happening in the entire environment, because we need to remember that the environment works as a whole unit. And of course, there's a lot of hands-on of how to do things too. And then our free Zoom meeting every Thursday night, and that is what this is. And then I have my YouTube channel that I put random things on from time to time. So let's get into tonight's presentation. And last week, we had a question of converting a piece of land into producing food. Now, this is one of the most exciting things. This is what we do in our 17-week class. We take land that's not doing anything, we convert it into a food production system. There's a popular thing in the environmental world today called desertification. It means degraded land. That means land that doesn't produce food. It means land that is going from like production, and then it turns into nothing but sand, silts, clays. There's no soil really, and if there is soil, it's a dead soil, therefore it's dirt. And we turn those around, and you can do that pretty quick. It takes 3 to 5 years to turn that around into being extremely productive if people know what to do. So that's the thing that I teach. That is the whole overarching purpose of what I do. So we're going to go through part of this slide tonight. I have a whole bunch of slides on here. I've put a bunch of pictures in here so people can see what I'm talking about. I added pictures of things that people have asked me in the past. I think last week, John asked what a roller crimper was. So I have a picture of it tonight. So there's just quite a few things that I tried to add tonight to be able to do an overview of what it is we're talking about. In most of the free classes so far that I've done, they have been about a specific subject. So tonight is an overview. So if you look over here, I'm going to get my cursor out if you can see that here. I've got this list of understand fundamentals. I have 10 things numbered there. When we understand these 10 things, and I got to be really clear here, when we actually understand them so that we can get a blank piece of paper and a pencil, and we can spend about 4 hours, and we basically write up a thesis about all these 10 things and how they interact with each other. When our knowledge level gets to that point, we have food freedom. And that's why I started my class, all my classes, because I want people to be able to get to the point of food freedom. There's no reason that food is not available to every human person on the earth. I mean, there's obviously reasons because there's hungry people, but there's not a good reason. It's a lack of education and a lot of other things. There's socioeconomic problems, there's political upheaval, there are obviously reasons. But when we understand this right here, it frees us, and it's so beautiful. So we're going to go through these 10 things tonight, and then we're going to pop over to this other list at the end, and this one's going to go pretty fast. So this is going to be a little bit longer presentation. My presentations are usually around 20 minutes. This might take a little bit longer tonight. I have no idea because I didn't practice it. But just be prepared. It takes a good 3 months to really explain these things clearly. And we're going to try to do it in 40 minutes tonight. So hold on to your seatbelts, and we are going to fly through this as an overview. That is the purpose tonight. And then in classes, I think probably maybe for the next 10 weeks, we will just take one of these and we will break them down. I'm not promising that, but we could do that if people want to talk about it. So here we go. Just so you know, I didn't make this stuff up. These are my teachers, my mentors, my friends. Some of them are old, meaning that they have passed away a couple hundred years ago, but they left behind good books. Take a quick screenshot of this. I'm going to go to the next slide in about 5 to 10 seconds. But if you want to read some of the smartest people in the world, get your screenshot of this, and this is where I got my education, among others. These are the highlighted people. Okay, I'm moving on. So let's start with number 1 on that original list, the 1 through 10. So like I said, these 10 things are going to be an overview of the principles. Number 1 was what makes a functioning soil. When we talk about a functioning soil, when I give speeches and I say a functioning soil, I have done this before. It's a terrible thing for a speaker to do because it makes the speaker look like he's better than everybody else. So I should do this, but it has been interesting, and I have done this, and I apologize. I probably shouldn't never do it again. But at the beginning of a speech, I say, how many of you have a functioning soil? And most people raise their hand. And then I say, how many of you people are using fertilizer? And everybody raises their hand. Let me be clear. If you are using a man-made input to your soil, it is not functioning. Okay? A functioning soil is when you take everything on that previous list, that 1 through 10, when you apply all of those principles, then the relationships of all of those put the ecosystem into balance. I don't know how else to say this, so bear with me, but it simply puts it into balance, and then plants will grow automatically without farmers out there working so incredibly hard to grow the food. And there are people doing this. And as chemical companies and as universities and graduates with really awesome degrees, I'm not saying that, I'm not being facetious about that. They have legitimate good degrees from the best agricultural schools in the world, and the things that they have learned are extremely valuable. I'm not putting that down at all. Don't get me wrong. Now, when these groups hear this type of thing, they struggle to understand it because it doesn't go along with what they have all learned. Okay. And yet we have people in the Sahel who are illiterate. That's Africa, Central Africa, Southern Sahara. And they are proving all of us with all of our knowledge wrong because they are following these 10 principles and they're not using fertilizers and they are growing food. It is actually working because they are creating functioning soils. So wouldn't it be nice to be able to create a functioning soil so that we weren't spending hundreds of thousands of dollars on our fertilizer bill every year, you know, on a 5,000 acre farm or whatever. And so anyway, functioning soil, it needs no man-made anything to grow food. And we, as we go through this, we will explain why. Well, if you don't put pesticides out, the bugs eat it all. Well, not necessarily. And there's ways to fix this. So get your screenshot quick. I'm moving to the next slide. Okay, the second thing about functioning soils we need to know, by the way, the first one is, what is a functioning soil? This is the second one. What destroys a functioning soil? We absolutely need to know. And that's me on that backhoe. I'm driving that backhoe. This is when I built the greenhouse that I have here, my underground, my Wallapini style solar greenhouse. And that is the 10-foot tall stone wall as I began to build it. Now, we drove over this ground many times, like hundreds of times, probably not thousands, but hundreds of times. We took bulldozer over this ground. We took the backhoe back and forth, pulling in all these boulders. We absolutely destroyed any soil that was there with compaction. And then now I'm growing a beautiful garden in there. So it's, you know, if we do compact the soil, can we grow food on it? Absolutely. We can heal the soil. We can absolutely make destroyed soils function again. But if we don't know what destroys it in the first place, it's hard to fix it. Now, number one on here is tillage. We till way too much. Is tillage morally totally, absolutely wrong? No, it's not. But does tillage kill the microbes in the soil that give us free fertilizer? Yes, it does. Do we find tillage systems in the most productive soils on Earth? No, we don't, because those are found in nature in old growth forests. And there's ways that we can measure that to know. I mean, how many calories is 1 acre producing in the redwoods? Well, it's more than any agricultural production that we have ever had. No, it's not calories that translates into human food, but it is calories. And so how does that soil do that? Well, the soil is functioning. And so we're going to explore tonight a little bit about how that happens. The second thing are sides. A side is something that kills something. If it's a homicide, it's a human. We killed a human, okay? But in agriculture, we talk about pesticides, herbicides, fungicides, nemicides. There's a lot of sides that we can use in the agricultural world that destroys the functioning soils. So we're targeting one specific something like an herbicide, and it will kill a lot of the microbes that are actually our best friends. And it's only been in recent years that we have figured this out, which is pretty great. So number 3 of the thing that destroys a functioning soil is compaction. And we've already talked about the backhoe, but adding lime, gypsum, all of your other salts that are in the forms of fertilizers. The definition of a salt is something that dissolves in water. So all of our fertilizers, man-made fertilizers, they are salts of different types. All of these things contribute to compaction in a lot of different ways. And then, of course, traffic. Too much livestock traffic, too much human traffic, too much machine traffic can certainly cause a problem. And below that, on that number 1 down there where it says anaerobic, all compacted soil, no matter how we compacted it, whether it was the additives to the soil or too much traffic, it causes anaerobic conditions. When our soil is anaerobic, which means a lack of oxygen, that's when we have problems with pests, disease, low plant vigor, and low yield. That's when we get those problems. So if you have a garden or a field that is having problems with pest and disease and low vigor, almost 100% of the time, what you have are compaction problems. Not always, but almost always. Okay, next slide here. So our next list on the 10 big things is the 4 ecosystem processes. To teach each one of these 4 takes at least 2 hours to do a good job. So I'm just going to tell you what they are. Energy flow is the sunlight. All energy on Earth, all food on Earth comes from the energy from the sun. It hits plant surfaces, plant leaves. The plant leaves absorb it. They turn it into so the light is the power, and then it turns chemicals into sugars. The sugars are stored, changed into other things, and they can be stored in the plant or in the roots, which is the plant, but then they can be exudated out of the roots into the soil and feed the life that's in the soil. So that's energy flow. So number 2, the mineral cycle. The mineral cycle is an ecosystem process of just the flow of the way the minerals work. And within the mineral cycle, we can talk about the nitrogen cycle, we can talk about the carbon cycle. We're always talking about the soil food web and all the little critters that are down in the soil and what they're doing. They're mineralizing, making the minerals available for plant growth. Okay, so that's the mineral cycle. Just one more quick thing to say about that. The bacteria and fungus will be making they will be mineralizing the sand, silt, and clay particles for most of your trace elements. Things like, molybdenum, manganese, iron, all of those little guys. They get turned into plant nutrients. The other thing that the bacteria and fungus does is they will decompose plant material that is dying. Okay, so they will mineralize and make plant food from both rock, which is sand, salts, and clays, or plant material, and dead animals too. But there's not a lot of those in the world compared to the amount of plant material we have. So the next one, number 3, is the water cycle. That's our ecosystem process of how the water goes from the bodies of water and the soil and plant life. It goes into the air, it condenses into clouds, it travels around the globe as water vapor, it condenses, and then it comes down in the form of precipitation. We can get snow, hail, rain, probably dozens of forms of frozen vapor that comes down on us. Ask somebody from the north, they have different words for snow. I call it all snow, but it comes in all different shapes and sizes. And so that's the water cycle, and the water cycle is highly misunderstood, and we need to understand it. The last one is number 4, ecological succession. Some authors talk about ecological succession, and they will have another term called community dynamics. Technically, they're different, but they are used in the scientific community interchangeably. So ecological succession or community dynamics is, depends who you're reading. But this is the idea that the earth starts out as bare stone. Think of Hawaii and the volcanoes. So you got the bare rock, it's formed, it's there, it's new. So we have a brand new island that pops up somewhere, or the borders of the island gain 50 acres a year because we are producing new land. Well, it doesn't stay rock forever. You have mosses and lichens that start colonizing the rock, and eventually you will get dust in there, and it will support annual plants with very shallow root systems. And then as the soil gets deeper over a period of, it could be years, it could be decades, it could be even millennia of that soil getting deeper and deeper as the earth changes, Then your perennials, your grasslands, shrubs, you've got your deciduous forests. You finally end up with old growth species, old growth forests. And anyway, so there you go. That is as quick as I can do the 4 ecological processes. So let's move to the next slide. And then we move on to the 7 soil health principles. Of these 10 things to understand, these are the ones that we're actually doing. No, there are other things that we do, like this doesn't say planting seeds, but as far as a principle goes, like we don't go out there and we don't mineral cycle, like on the last slide. You can't go out there and mineral cycle, but we can understand the mineral cycle. And in order to have our farm take advantage of the mineral cycle so that it's working, so that that soil is functioning and the mineral cycle functions within the soil, then we can use these 7 soil health principles to be able to do that. So these 7 things are the things we actually do. Mindfulness is highlighted in red because I added it. So I don't know if that's legal. Pretty sure there's not a law against it, but the other ones, the other 6, you know, they have been, I mean, I learned those from people way smarter than me. So, but as I've been teaching this over the years, especially in the last couple of years of having people come to the ranch here and learn, there was something really missing, because the way a person approaches their work either makes the 4 ecosystem processes thrive or they don't. And that you can even hurt those 4 ecosystem processes, because you could go out there. Let's just look at number 2. So first of all, let me define these. Mindfulness is being aware of the present moment. You're not worried about the past and you're not worried about the future. Mindfulness is seeing what you are doing right now and understanding right now what's happening, and you observe right now. And so that's mindfulness. We don't worry about the past, we don't worry about the future. And you know, I would be teaching people this stuff and they're like, oh man, but I have to make a profit this year. No, you are worried about the future. And so that is going to mess up what you are doing on your farm if you are not mindful, because you will not let the ecosystem teach you what is happening right now. You will miss things that are happening and you won't be able to become better. You will not progress. You will keep doing the same thing on your farm you've been doing the last 10 years. And in 3 more years, you'll be bankrupt because you have never learned what the soil has tried to teach you. Now that could sound a little bit silly, but this is the only thing that has worked in agriculture when you read enough people involved in agriculture. So mindfulness, you got to be clear of what's happening. Context, you need to know what you're doing. You got to understand your context. Is your context, you know, to grow apples in the Sahara? It's probably a bad context because you're not going to have enough water to keep those trees alive. You know, is your context to grow oranges in the mountains of, in the Wasatch Mountains of Utah? Probably a bad context. If you want to grow oranges, you need to go to Florida or California or somewhere else that can grow them. So context matters, but you would be surprised how many people have their context messed up. Minimal tillage. I used to call this no-till because there's been a thing called no-till for 30 years. And it's the same thing, but really what it is minimal tillage, because I do till the ground when I plant transplants. We're digging holes in the ground to plant. So there is some tillage, but it is very minimal. Number 4, keeping the ground covered. That means you keep the detritus on top of the ground, the plant material. You never ever want to see bare soil. There's 2 ways to keep the ground covered: with living plants or with decomposing plants. But if you see any dirt particle, your soil is not going to function. Number 5 is diversity. You want as much diversity as possible. Monocrops don't exist in Mother Nature. And so it destroys the soil when we have monocrops. So we need to be growing many different crops together, which is it's not popular, and it's probably not convenient. And it's a completely different mindset of the way we've done it. I put this picture in here because it does show the diversity in my greenhouse. And, you know, I think I have 12 plant families in this greenhouse, but almost everywhere I have at least 4 plant families who are growing close enough together that their roots are mingling under the soil, and that helps with pest and disease problems and fertility, which is pretty awesome. And we can explain the science of how that works later. And then the living root, look at that, it's a typo. It says lining root. Man, I'm the guy who edits this, and that's a problem. So a living root in the soil. The living roots feed the microbes, and it collects carbon from the atmosphere, and it puts the carbon into the soil, which is free fertilizer. So we need to have a living root in the soil all the time. And then number 7 is animal impact. We can't just do it without the animals. We have to have a complete ecosystem. When we try to do it without animals, it doesn't work. So we have to have an animal impact. So when Elon Musk goes to Mars, he needs to be taking a milk cow with him. I actually think that's true. So the 4 key insights, this comes from Alan Savory's teachings. There's the predator-prey relationship, timing, wholeness, and brittleness. So the first thing to understand, the reason I put this ecological succession chart by these 4 key insights, these are 2 different things, but the 4 key insights are easy to explain by looking at the relationship with the ecological succession. That's why they're on this slide together. So the predator-prey relationship, predators, and let's just assume humans are predators because we are. So the predator-prey relationship keeps the prey animals on the move. Think of the Native Americans, 300 years ago, moving the bison across the Great Plains. Wolves were moving them. There were probably other predators who were moving large herds of grazers. And so it kept the grasslands in a mid-successional state, which it was actually a climax community. So it wasn't changing, it wasn't evolving into trees, because there was a keystone species of the human and the bison. Both of those were probably keystones, and they were keeping it a grassland. You take away the bison, what happens? Well, something's going to happen. It's either going to go to the left on this chart and it's going to turn into a desert, or it's going to go to the right on this chart and it's going to turn into a forest, depending on how much humidity is in the air. But that's technical, and that's not an overview thing. So timing, number 2 is timing. Timing is vastly important, whether we're going to go right or left on this chart. If we're going to turn into a desert like the Sahara, because if we read the ancient documents and we read the most modern documents of the Sahara, we know from both of those records, from modern science of what's under the Sahara and from ancient literature, that the Sahara used to be a grassland and forests and all kinds of things. And so it went to the left on this chart. It turned into sands and rocks across the Sahara. So we're way over here in early succession. Biggest desert on earth, early succession. It used to be something else. It used to be a grassland. I did not mean to move the slide. And so we have that choice of what to do. And timing is one of the key insights in our management. We need to know when to do what. If we don't understand timing, we could go on for 10 years making all kinds of decisions on our farm, and every year we lose a little bit more production, a little bit more, and we don't know why. And it's usually because people don't understand timing. So number 3 is wholeness. This is just the idea that everything works as a whole. This is the argument that a lot of the great scientists are talking about right now. People like Ray Archuleta, a lot of them are arguing the idea that that reductionist science needs to work like a hand in a glove with holistic science. They need to be working together. And instead of the reductionist people, which is most of our universities, instead of them saying, here's how it's done and that's that, everybody needs to open their eyes and work together, because an ecosystem works as a whole. If I have an ecosystem and it's covered with oak trees and I cut down all of the oak trees, that's going to be a major, it will have major impact on that ecosystem. And so what will happen if you remove a species? And so we have to ask that question. But that's just the idea of wholeness. The whole thing is working together. So when we make decisions, we need to be very careful on what we do so that we get the result we want. Because sometimes we do something and we get an opposite result of what we thought we would get. And that's where the problem is. And then number 4 is brittleness. That's the brittleness scale. So that means you are in a very humid environment or a very non-humid, a very dry or brittle or arid environment. So I live in the Great Basin Desert in northern Nevada, and we are in a brittle environment. We're in a very low humid area here in the western United States. Now, if I went to the coast of California and Oregon and Washington, that is a much less brittle environment because they have a lot more humidity. And that matters because of the way things decompose. So if you live in a non-brittle environment, your timing of number 2 of when to graze your cattle will have a different effect than if you are in an extremely brittle environment. So it's more important to have cattle grazing on brittle environments to stop it from desertification than to have them on non-brittle environments. There's a lot of people who are trying to do good things in this world, and they make statements like, if humans were gone, the world would, all the other species in the world would thrive. That is true in a non-brittle environment, but without a human in a brittle environment, we have major problems. And obviously we don't have time to go into all that tonight, but knowing what to do and when to do it, it's very, very important. That takes us to the 6 spheres of the soil. This is super exciting. Within the last year, Ray Archuleta has added the philosphere to this. So all of my students that have gone through my classes, I've always talked about the 5 spheres of the soil. So I sent out emails. I sent out emails when I learned this to my people who've been in my classes. And I said, hey, they've added a 6th sphere. It's called the philosphere. So we'll just go through these and define them really quick tonight. The philosphere is the leaf surface of the plants that collect the sunlight. They make the sugar goes into the soil. And then the detritosphere is the dead organic matter on top of the soil. The agrotosphere are the aggregates that are formed by the microbiology life in the soil. And the porosphere is the negative space of the agrotosphere. So when you dig up in the ground, your soil should be a cottage cheese texture, and each little ball of cottage cheese texture soil is going to be your aggregate, and between the aggregates are the pores. So all that airspace in between is your porosphere. And then you got your rhizosphere, which is the roots in the soil. And then the drillosphere is the earthworms and anything else that would burrow down. So I guess a squirrel or a gopher or a mole would technically be drillosphere. But we don't necessarily like those. But I think, like, just from a scientific point of view, the drill-a-sphere would be any holes drilled into the ground. These spheres are absolutely important, and this is why we don't want to till the soil very much, because what it does is it collapses the agrotosphere and it breaks them up, and then your clay minerals are all going to be, your clay colloids, they'll all be stacked together like sheets of paper, and then the water can't get in, and you create compaction. You have no porosphere, so air can't get in, and then your rhizosphere can't penetrate deeply through the compaction. And yeah, anyway, big problems if you don't have your 6 spheres of the soil. And then that takes us to the 8 important groups. I've got my daughter here looking in the microscope, and the way we know if these groups are here is we look at the microscope. That is my microscope in my laboratory where I do my soil samples. And these are the 8 groups we're looking for. Bacteria and fungi, they're the ones who do the mineralization, like I said before. But the protozoa, they eat the bacteria. Nematodes will eat protozoa, fungi, and bacteria. Microarthropods will eat anything that fits in their mouth. So they'll eat all of these guys that are smaller than them. And then they will also, they rip and shred a lot of the plant materials to break them down into smaller parts, which is very important. And then there's macroarthropods. The difference between microarthropods and macroarthropods is how big they are. So if you need a microscope to see them, it's a micro. If you can see it without the microscope, it's a macroarthropod. So these are bugs. These guys have legs, they have bodies, they have antennae. These are bugs, the micro and macroarthropods. It includes insects, but all your other bugs too. And then incatraids, those are like a worm, except they're not genetically related to earthworms, and they're a lot smaller. They're white, they're about 1/4 of an inch long, but I think different species can be different sizes, so don't hang too much weight on 1/4 of an inch. But they're just these little tiny guys. They look white, but they're actually kind of translucent. If you look at them with a magnifying glass or under a microscope, they're translucent, meaning they're clear. And then earthworms. Earthworms are pretty common. I'm sure you've seen earthworms. But we need to have these 8 important groups in our soils so that the soils can function. If we don't have these groups, the soils don't function very well. Now, not all soils need incatraids. Not all soils would need earthworms. But, you know, all soils need a minimum of the bacteria, fungi, protozoa, nematodes to create the nitrogen cycle, to create the just that entire mineral cycle so that the plants don't need fertilizer. Now we'll get on to the purpose of pests and disease. We have to understand that pests and disease are not simply something to make us worry. They have an ecological purpose. And this is something I did not understand until recent years. This is a new thing I have learned. And it's wonderful when you learn this, because it frees us up to do some incredible things in the world. So the ecological purpose of a pest or a disease, they decompose plant material. They are the cleanup crew of unnatural phenomenon that happens in the world. And they are renovators. They fix things. We can use certain pests and disease to do beneficial things for us. It's not like we would bring in a pest or a disease, but if we understand its role, when we see it, we don't need to freak out. We just need to understand what is happening. And usually the pest and disease explosions that we have are because they're usually a symptom of bad management that we have done. Like if we see a whole bunch of grasshoppers that have like a plague, there's a huge plague of grasshoppers, and oh man, they're going to come through and wipe out our grassland. We won't have any winter feed for the cattle. That can be a serious problem for a cattleman. But that is a symptom of the ground being bare, because grasshopper, the little, they're not eggs, but they're like eggs. It's a little, it's like an encasing. I forgot the name of it, but it holds the grasshopper's eggs. Those only will break open and hatch new grasshoppers if you have bare ground. You don't have grasshoppers hatching on ground that is covered. So if we are keeping our ground covered, then we don't have a lot of these ecological problems happening. I put this picture in here. I want to talk about it. This is a perennial pepperweed, and people hate it around here. They consider it a terrible invasive species. It's not poisonous to cattle. Cattle will graze it and eat it. Sheep can graze it and eat it. It doesn't hurt anything. It's not filled with alkaloids. It just frustrates people because it grows when we wish there was something better growing. But it will only sprout and grow in compacted soils. And so it's an indicator plant that tells you that it's an early succession plant. Remember our chart on succession? So this one is it's a perennial, but it's still an early succession, and it's trying to grow, and it has a taproot that goes down to break up compacted soils, which is pretty great. I'm not saying we should have this around, but look at the disease that is on it. So I did a side-by-side comparison test this year in one of my new gardens that we started. We were converting over some old land into a garden land, and there was perennial pepperweed all over it. And by inoculating with the proper microbes, which you saw in the last slide, the bacteria, fungus, protozoa, nematodes, all those, we inoculated the ground with those. So as the soil started to function, these plants began to die out, which is what happens. We don't need as many herbicides as we once thought we needed. We simply need to restore the function of the soil. So this is pretty awesome. We documented this in our class last year, and we're going to continue to do it next year. It'll be one of our main projects. It's going to be great. Okay, there's 7 layers of plants. This is something we learned from the permaculture people. The Permaculture Institute publishes this, and I really love this. And I put this with the energy flow chart. Not that they go together. They don't necessarily go together, but it's just fun to see them together. But your overstory trees are the big giant trees. Your understory would be your smaller trees, like the size of a fruit tree. Then you got your vine layers. Those are things like grapes that grow upward up trees. And then the shrub layer, that would be a plant like a blueberry or a goji berry. And then the vegetative layer, those are shorter plants. Think of rhubarb. And then ground covers, think of your lawn, or a creeping vetch or something like that. And then the root layer, well, those are the roots that are going down in the ground. So these are the 7 layers of plants. The reason I put this energy flow chart with this is because this is how we maximize photosynthesis. If you only have one layer, let's say we have a 1,000-acre farm and it is corn. The entire thing, we planted to corn this year. Next year, we're going to do a crop rotation and we'll grow soybeans. I used to live in Missouri in the farmland there, and that was what people did. So this year, our 1,000 acres is corn. So do we have an overstory? No. Do we have an understory? No. Do we have vines? No. Shrubs? No. Vegetative? Yeah, we could probably call corn a vegetative layer. So we have one layer. So how much photosynthesis are we getting? Well, we are getting what it can grow depending upon the leaf shape and size of the corn. Okay, so that's going to add a tiny bit of carbon to the soil, and we are going to get a certain amount of food per square foot, or calories per square foot, calories per acre coming off of that. And our soil health will probably not be maximized at all with one crop. But let's say that we grew 3 other crops with the corn. And I mean, what would those be? Depending on where you grow, where you are climatically, like if you're in the south or the north, things would change. But the Hopis used to do what they called the 3 sisters, and they would have beans, corn, and squash and melons. Squash and melons are the same thing botanically. So they would grow those things together, and they called it the three sisters because they would grow well together. Now you have three plants growing together, different leaf shapes, different sizes. You're getting more carbon into the soil, still not a lot because those plants don't necessarily collect a lot of carbon, but it does some, and every bit helps. And then the maximizing of food per square foot. Yeah, you got a lot more food on your, because now instead of getting corn, we also got beans, and the beans are going to help the nitrogen cycle, which could help make a bigger corn crop. They're not going to compete. And what if you had a disease come in? Well, there's a possibility that your disease isn't as bad because you have these three different plant families growing together. And so you may have enough plants growing that you're maximizing what are they, the little guys in the soil, your microbiome. And when you get a lot of those guys, when you get 400,000 or 500,000 species of those in the soil, they're going to turn on the secondary metabolites in the plants themselves. And that gives you pest resistance and disease resistance. So instead of having all the corn, like corn borers or whatever else coming in to lower your yield on the corn, it could even be grasshoppers, whatever. The sugars in your corn leaf are going to be high enough that a lot of those pests aren't going to eat the corn. So now we're good. Anybody listening to this, I just want to make sure that you really need 4 plant families growing together. So in our example, I mentioned 3. You really need 4 to be able to turn on secondary metabolites. So maybe you would want to plant a bunch of, you would want something else that's low growing in that cornfield. So what could it be? Well, you could put potatoes in there too. How are you going to mechanically harvest this? Like I said, this is going to take some new thoughts, some new inventions. So is this completely practical to do this? Absolutely, on a home gardening scale. On a bigger scale, no, you wouldn't grow potatoes in that field. It wouldn't work. But would that be a different plant family? Yes. So would it give you the greatest possibility of pest and disease resistance? Yes. So what if we went in there and planted something like vetch? That would work. There you go. We just solved it. Okay, next slide. Keystone species. I think this is the last thing on our original list of 10. Or 10 things. So keystone species. There's a lot of keystone species, but there's 2 keystone species that are not being talked about enough in our world. And that is humans and beavers. First of all, let me give you a super simple, quick definition of a keystone species. A keystone species is a species that if it is removed from its ecosystem, the ecosystem collapses. That's why it's called a keystone. So thanks to Wikipedia, I pulled this picture into my slide here, and they've got it highlighted. The keystone is highlighted as red there or pink or whatever. And if we remove that keystone, this arch crumbles and falls. But if we leave the keystone and we make sure that keystone stays healthy, that arch could stand for hundreds of years. I'm sure there's arches in Europe that are hundreds of years old. So humans and beavers are keystone species, but we need to be doing the right things, making the right decisions so that we have the environment that we want. So that's why context matters, because we need to know what we want within our context. Let me just tell you a quick story about beavers. Beavers are keystone species to the water cycle. When we removed the beaver, when did we remove them? Hudson Bay Company, 1800s. There were some years in there where they harvested over 200,000 beavers a year. And that impacted the water cycle in North America. And so the water went from, I think it was 3% water in the 1700s, 1600s, 1700s. That's surface water, lakes, rivers, streams on North America. And now it's less than 1%. So I think, you know, it certainly has changed, but in our modern world, that isn't the story I was telling you. Here's the story I want to tell you. We don't see beavers as part of the water cycle. When I was writing my book, it was obvious to me that beavers are part of the water cycle. And so I went to the internet to find a diagram like this one of the water cycle. And I just went to Google, I typed in diagram of water cycle and clicked images, and a whole bunch of them came up. I went through 200 pictures, diagrams like this one that you can see of the water cycle, and they all teach the same thing. And most of them were pretty good drawings to help somebody have a visual of the simplicity of the water cycle. Not one of those had a beaver in it. And I thought, forget that, I'm doing my own thing. So I had my daughter-in-law draw me these diagrams. But what did that teach me? It taught me that modern people in science who are using these diagrams to teach classes, they don't even understand the water cycle. The beaver is absolutely a keystone species for our ecosystems for the water cycle. And anyway, I can argue that for a long time. Let's move on to the next slide. Oh boy. Here's the conclusion of all of that. Better see what time it is. See, it's 9 o'clock at night. Wow, I've almost been going for an hour. How amazing. Time flies when you're having fun. I thought it'd been 25 minutes. I'm sorry if I bored anyone. Conclusion of these 10 principles tonight. First of all, I put the principles over here on the right side. You can see my cursor here on the screen. So here's the 10 principles we just went through. We need to understand these fundamentals and how they interact with each other, okay? But let me just conclude this by looking at this other side. How does this actually help us? When we can understand and incorporate all of these things together on our own farm, let's say we have 5 acres, and when we use all of these properly, we are not going to have to buy any man-made fertilizer. We won't have to buy anything to adjust pH because the soil is functioning, okay? We won't have to buy any herbicides, pesticides, nemicides, no sides. We don't have to kill anything because the soil is functioning and the plants will be so healthy that they will have their own pest and disease resistance built in. And then we have fewer passes with the tractor. So on our 5 acres, we may not even have a tractor. But if we had 50,000 acres, like there's our farms that big in the US, and those guys are spending millions of dollars a year just on these inputs we're talking about. Well, maybe up to $1 million. But so if you can take your passes of a tractor, say you do 5 passes in a year, let's get it down to 2. Let's get it down to planting and harvesting. And so that saves you an amazing amount of money on fuel and labor. And then there's the bioremediation. And so if we have polluted land, we can clean up that pollution because there is land that won't grow anything, or it's against the law to grow something there because it's been polluted with whatever, heavy metals, whatever. We can use bioremediation to fix that. And here again, it's pretty quick. In under 10 years, we can reclaim old land. And then probably the most important thing is we have healthier food for people to eat. And if you're in the business of selling food, which a lot of farmers are, probably most of them, you can charge a little bit more money. So you can have your incomes a little bit better if you can prove that you actually do have a healthier food product. And then there's the resilient biology. And what does that mean? That means that your food grows in extremes. I just heard on the radio right before I started this class tonight, the US is right in the middle of one of the worst winter storms we've ever had. There's like 1,000, I think they said there's 2,500 flights that have been canceled in the United States, people going home for Christmas, and their flights are canceled. I just heard this like 2 hours ago. And because it's the worst winter we've had, terrible winds, lots of snow, and they're worried about ice storms, just lots of upheaval in our climate right now. So we need to have food that will grow in extremes, or we face food shortages and famines and all that kind of stuff. So by doing these 10 things, we do build resilient biology. And then how do people fail at this? People fail because they hear about this and then they're like, okay, I'm all in. I am all in. I'm just going to do it the regenerative farming way. Right now, I'm in with both feet. I'm switching over and I'm not going to buy any fertilizer this year. I'm not going to adjust my pH. I'm not going to spray for anything. And I'm only going to plant and harvest. That will absolutely bankrupt you. This needs to be done with mindfulness. We got to go back to the 7 soil health principles. You got to go back to mindfulness. You have to have a plan. It usually takes 3 to 5 years to implement these things to get your farm from where it is to a functioning soil where these things that we've talked about tonight are actually a reality. Oh, I need to take a breath. Okay. It's been an hour. Let's open this up for questions. Questions. Go ahead and type in the chat your question. I'm going to stop sharing for a minute. If somebody wants to see one of these slides, I can turn it back on, but go ahead and type in the chat or unmute yourself. Ask me questions. That was a mouthful. That probably scared you to death. But like I said, it takes 2 or 3 years to learn this stuff. And this was just an overview of what I teach in my school and why. And
yeah, no, we really appreciated this list. Like we said it last week, we're just planning to get started. We've both done individual gardens over the years, and then we got married and we started working on a garden together this year. We're finally in a place where we were there for long enough to really try to do a garden together. And so it was fun to get started and try things out. But we knew when we got the soil that we ended up buying to fill our raised beds that it wasn't good, because we went for probably, I don't know, 2 or 3 weeks before we planted anything, and nothing was growing in it. There were no weeds. There was nothing going on. I was like, this soil has nothing in it. What did we get?
yeah,
So,
okay.
But now we go down there and, you know, if I dig around and find potatoes or whatever that we grew, because we got a few things, and we actually got a lot of tomatoes, but we do find more of the cottage cheese kind of feeling. And there's actually worms in there now, you know, things like that, that just in one season. Now, the thing is that we're moving, so we won't be in the same soil again because we're moving. But like we said last time, we're moving to an area that used to be a pasture. And right now it's almost entirely goat head weeds and lots of ant hills. And then there's cow patties that look, you know, like they're dried, but they're still there. So it must have been a pasture in recent time. It would seem like it would have, you know, kind of broken up, you know, before that. So I think it's been recent time. It was last a pasture. But anyway, we have to kind of start from ground zero.
Yeah, okay. So where are you? What state are you in?
We're going to be in Idaho.
Okay.
And Payette, and it's like at what, 2,100 feet?
Yeah.
2,100 feet. It's kind of a high desert kind of thing.
It's a treasure island.
So anyway, we have lots of great plans, but we're total newbies. So
All right, good. Perfect.
so we're definitely going to start small and manageable.
Yeah,
We're
super
been
important.
trying to research our area for what kinds of things grow there, what kinds of things don't really grow there, just to get an idea to where to start. So
Okay, good.
mhm.
Yeah.
So I guess our first step would be to figure out what kind of soil we have.
Maybe.
Yeah.
I mean, probably the first step is, do you have a list of the food you want to grow?
Yes.
Yeah, we made a list.
Okay, so you got your food list. Good. And how much land are you working with?
Well, we have a total of 2.9 acres, but that's a lot of, so we need to start with a smaller garden, maybe, I don't know, 10 by 20. I don't know, what do you recommend for a starter garden?
It's just the two of us, so it's not like we need a ton of food to start. We just
Yeah,
want to make
and you've both gardened before, so
various ways.
you know how to grow plants.
Yes.
Okay, yeah. Yeah, so just start with something small, something like 10 by 20, 15 by 40, whatever.
Then we also want to build a wallapini. That's how I found you, was trying to figure out, because, you talk about citrus and high desert and not Florida, California. I love oranges. I love avocados. So wallapini might let it.
Yeah, yeah. Yeah, mine's nice. I love it. It's a good thing. We talk about context and how building a great big commercial greenhouse is kind of out of context for certain things. For our context, it's perfect because we're trying to feed 15 to 20 people right here.
Mhm.
And we have an 80-day growing season on good years because we're at 6,000 feet and right at the base of the East Humboldt Mountains. And the old timers here say that they've seen frosts here every month of the year. So if we
No.
actually want to grow our own food, we have to have some kind of protection.
Mhm.
So that's why we built the greenhouse. We felt like it was certainly in context with what we wanted to do. We're after a quality of food that is hard to find, and and I can grow it. So go ahead and build the greenhouse. That's our rationale. So
Mhm.
yeah, so I have more slides. We will continue next week
Sounds good.
on what to do. I went in the greenhouse. I took pictures of, but it's hard. Here's the thing, and that's why I went through these 10 points tonight. If people have never even heard these principles we talked about tonight, they don't do the things I tell them to do. Because so many times I've said, oh, do it this way. And they're like, oh, yeah, that makes sense. Yeah, we'll do it that way. And I talk to them 3 months later and they say, my ground's drying out too much. And I'll say, well, do you have it covered with 6 inches of some kind of mulch? Well, no, I decided not to do that. Well, so it's just bare dirt? Yeah. Well, why is it bare? Because when you started, it had 2 inches of grass clippings all over it. Well, we tilled it in. Well, I told you you shouldn't till it. Well, we decided to because we have a cool tiller. And so that's why I spent so much time tonight just going through those principles. And obviously hearing them once isn't enough to really understand them. Like I said, we take months to teach these to our students, but it's but at least having heard them, it starts to make sense when we get into actually what to do.
Yeah.
So yeah.
Awesome.
Hey, do you have any specific questions about what to do in the next week with your farm or anything? Or
I don't think right now. I'm looking forward to maybe next week you were going to continue with that second side of the slide that talked about how to start.
yeah, I'll go into that next week. I didn't think I was going to take
Covering
so
your
long.
ground, all those things. We did do cardboard before we started our section we did this year.
Okay.
But because I had
Good.
heard that before.
Yeah, good.
So we'll definitely do that again. But anyway, we'll be interested to hear your practical steps to get started next week.
Okay, yeah, we'll be going into them. So that's good.
Sounds good.
Ezekiel, did you have any questions tonight?
I do actually. So this spring is going to be my second year working on the ground that I'm on. Over the winter, it started out with 8 inches of straw on everything, and 1 inch of quality hay. For the microbes.
When you say hay, are you talking about alfalfa?
I am talking about alfalfa, yes.
Okay, continue.
And so now for the last month or more, it's really interesting. while it was sitting there just in the sun, it kind of settled, and it got rained on and it kind of settled. And now it's had snow on it for about a month, and it's really shrunk. So it started out at about 8 inches, and now it's probably down to only 4. So it's probably gotten half as big, which is really cool. Where I put winter wheat down and very cold resistant mustards, I have shoots sticking up through the snow. So I have living roots in it. I got worms from you actually. And so I'm pretty sure I have a good worm community in there. And I'm gonna plan on, in the late winter, I have a fancy grow shelf thing I made so I can get my shoots, all 6-inch high transplants in there, right after my last frost date, which we have pretty consistently here in southern Utah. So my question is, do you think that my soil activity is going to be good enough that I don't need to focus on a lot of fertilizers? Or should I get out there and put fish emulsion and whatnot down? And if so, should I be putting it down now while I have the microbial action going under the snow? Or should I wait till right before I plant my plants? Or should I water after I plant my plants? I'm actually not good at knowing when to fertilize stuff. Sorry if that was a rambling question.
No, I think I've got enough information to give you an intelligent answer. Don't put out any fertilizer now. What you want to do, I think you're probably at the stage. I think you're probably at the stage where you could do a side-by-side comparison test. So just when the snow melts and you're ready to plant, go put your transplants out there, put your seeds out there, however you're going to plant it. And then as your plants begin to grow, fertilize like every 5th plant. Okay. So if you plant 20 tomato plants, fertilize the first one and then count 5, fertilize that 6th one in the row. And then, so you're going to fertilize a few. Watch them closely. And if you see that the ones that you fertilized are growing a lot faster than everything else, that means your soil is not yet functioning, and you better fertilize everything or you're not going to get a good crop. Okay. So that's the answer to that. And that's called a side-by-side comparison test. And what you're comparing there is the fertilizer. You can also do side-by-side comparisons with different species or different varieties within a species. But this would be a test to test the fertilizer. So fertilize it as soon as you transplant. And if you're planting seeds, wait till they get up about 2 inches tall and then go through and give them a shot of fertilizer. And I'm talking about like like you said, a fish emulsion or a fish hydrolysate, like just any super good, safe fertilizer. You could use any, you could use Miracle Grow if you wanted to. I don't always recommend that because there could be, if you use too much of it, it causes a problem, where with the fish products, it usually doesn't cause a problem if you use too much. So, but that's what I recommend for you. And then it tells you where your soil is, but you've only been doing this 1 year. So you're probably going to see a response from the fertilizer, and it will tell you this. But see, in 5 years from now on that soil, you keep doing the same thing. Follow all these 10 things that we talked about in this presentation tonight. And then in 5 years from now, you will be putting fertilizer out there and you won't be able to tell a bit, anything, because those plants won't respond to the fertilizer, because your soil will be growing so good that they're growing to the maximum genetic capacity that they have. So that's what you're looking for in this test. So that's what you do this year. And yeah, I think you had another part of that question about all your detritus on top that's melting down, the earthworms are eating it. It's working good. A layer of snow on top of your garden is one of the best things in the winter. Some of the scientists I've studied with, they've said that the most biologically active place that they can find anywhere in any environment is that spot right between the snow and the soil level. in the winter time, which is crazy because everything we're taught is that all your beneficial microbes, they like room temperature. There's all these things that we think we know. And then a researcher comes out and tells us something like that. And we're like, wait, hold on. But that's why this is so much fun. It's because we're right on the cutting edge of the new sciences, man. We're making breakthroughs all the time. So it's pretty exciting. So, I mean, I can't even give you any more information than that, but there's a researcher who found that that's one of the most active places, right between the snow and yeah, your soil. So in your detritus that's melting down right now, I'll bet if you went out there with a shovel and you moved back the snow and you dug down in the soil, and we took a soil sample back, we looked at that detritus melting down, it would be neat to see what's happening. You probably have living, active, all kinds of stuff. So that was a long answer, but I hope it answered your question. Any more questions tonight? Go ahead and ask them.
One really quick one. Should you fertilize if you have a worm bin that you're not putting a lot of stuff in because it's covered in snow and there's a lot of detritus stuff? Should you ever fertilize a worm bin? That might be a silly question.
No, not necessarily, but yeah, you could. You wouldn't want to use a man-made salt-based fertilizer though, because that's gonna mess up it'll throw things out of balance. The chemicals will get out of balance. You don't want to do that. You could dump a gallon of like not straight, but you would mix it up the way they say to mix it up, like a teaspoon of fish hydrolysate to a gallon of water. You could water your greenhouse, or not your greenhouse, but your worm bin with that. And because that is fungus food. Fish hydrolysate is going to help that fungal biomass to grow and to thrive. Another thing you could do to feed the microbes in a worm bin, if you got just a bag of oatmeal, just any old oatmeal, you know, just put that in there, because it has really like I can't think of the term, but it's fungus food. Lots of fungus food. I was trying to say fungal to bacterial ratio. That's the wrong thing. It's the I've been talking too much tonight. I can't think. But yeah, the fiber. It's all the dead woody fibrous type things. Carbon. That's what it is. Carbon to nitrogen ratio. That's it. It finally came to me. It has high carbon levels, and high carbon feeds fungus. And usually fungus is the thing you don't have enough of in a compost. And the whole reason for having worms is to build a great compost. So make sure that you're feeding your fungus.
Awesome, thanks.
You bet. All right, any more questions tonight? We can take a few more if you've got them.
Yeah, I have so many questions, I'm not sure where to start, so maybe we just need to keep learning and get the
Okay.
questions as we come, but it is we'll be ready to get more time on the property here, probably early spring. So I'm just wanting to, in the next few weeks, wanting to determine what my next steps are and what the critical path is to at least getting the soil and getting something in the ground.
Yeah.
So that's what we're looking at.
Right. Yeah. So are you dealing with a pasture situation right now?
Yes, we bought it that way, and so it's been on time. We bought it over a year ago, and we just
Yeah.
been working on building stuff, but
Right. Yeah. Well, start collecting cardboard so that you can put that on the ground to kill out your perennial grasses, because you can put that on your entire area, because you're talking about like a 10 by 20 or whatever garden area. There's not that much cardboard to cover that, so that'll be the easiest way. So get cardboard and then start looking for places where you could get some kind of a potting soil compost type material.
Right.
Sometimes you can get loads of like manure from old dairies or whatever. If there's landfills around that have compost they're giving away, you could get some of that, but you'll need a couple of truckloads of that to cover this with to get started. It's hard to find good potting soil / compost. because people don't know how to make it properly. So if you go to find it and it smells bad, don't get it. It should have no odor, or it should smell like a forest floor. It should smell really good.
Mhm.
If you
Oh.
pull into a landfill where they're making compost and you open the door and there's flies all over the place, obviously there aren't any in the winter, but if there's flies around and it smells putrid, it smells like rotten meat or a cesspool or rotten eggs, just turn around and leave, because what you'll be bringing home is all the anaerobic disease causing organisms, and then you're going to have to fix all those. So I would take some of that sometimes. If somebody paid me to take it, I would take it. Otherwise, I'm going to make compost from fresh materials, from
Mhm.
fresh manures. That if it's manure and it smells like it does when it comes out of the animal, that's okay. But you don't necessarily want it in a pile for a long time, turning anaerobic. That's not a good thing. So it can be hard to find, but start looking for stuff like that. You
Okay.
need a huge pile of wood chips, old rotten hay. If somebody's alfalfa gets rained on and they're gonna sell it at a discount, those are good places to find organic materials to start this with. So that's what you
I
do.
have a quick question about that.
Go ahead. Okay, go
What
ahead.
what if there's a massive pile of manure that's like 14 or 15 years old and is being taken over by big lush looking weeds, like
Okay.
mostly like amaranth and raggrass?
Yeah, if it's that old, if you've got anything over 7, 8, 9, 10 years old, you're saying 15, dig down into it. Take a front end loader, stab into that big pile, open it completely up. If it smells really nasty, it's still anaerobic, but there's a good chance that it is done with the anaerobic stage and it has gone aerobic again. That would be perfect. Unfortunately, they're not that easy to find. I mean, if you're moving to Idaho and there's a dairy that has a pile of manure that's been there for 10 years and they're going to let you take it, go get it and just dig into it and see if it smells bad.
Mhm.
If it smells good, like a forest floor, or it has very little odor at all, that stuff's pure gold.
Mm.
All right. So, so we'll have to think about some more things this week, but really appreciate tonight. We really earned a lot, and of course it's like a fire hose. I gotta let it soak.
Right. Okay, yeah, well, I'll be back on next week and we'll finish what we tried to get through tonight. So
Sounds good. Thank you very much.
Thank you.
You
Merry
bet.
Christmas.
Good
Yes.
night. Merry Christmas, everybody.
Right.
Good night. Thank you.
Good night.
All right.
Vernie, did you have a question?
Nope, just enjoying it.
Okay, all right. Good night.